Okay, so since I forgot to record the Google Meet for class today, I thought I would quickly kind of go through the notes here in a quick video so you can see them if you need to. Okay, so basically this unit we are taking all of the stuff that we learned in the last unit, the simplifying with radicals and cube roots and fourth roots, and then also all the stuff with imaginary numbers and putting it to use with solving equations. So in this first section here, we are solving equations where we've got x squared or x cubed or x to the fourth. Notice in these, there's only like that x squared. There's no x. So on these equations, we can simply get the x squared part or x cubed part by itself, and then take a square root to undo that squaring. So we've done stuff like this before. On this one, I can take the x squared equals 9, and to undo that squaring part of that, I'm going to take the square root of each side. Whoops. I can get my pen to work here. There we go. So then I'm going to do the square root, of each side. There we go. And the square root of x squared is x equals, remember, anytime you introduce that square root, we need to put on a plus or minus, and then the square root of 9 is 3. So we get positive 3 or negative 3 could be an answer there. Same idea on the next one, except this time I want to get that x squared by itself, so we're going to divide by 5 first on both sides. And when we do that, we get x squared equals 3. And then we're in the same boat there, so take the square root of each side. We get x equals, we still need our plus or minus. This time 3 is not a perfect square, so we just leave it in the radical. So again, it could be the positive square root of 3 or the negative square root of 3. Next one, same idea, right? Notice this time though, we've got a cube root instead of a square root, but we're going to start off the same way. So divide both sides by 2. We get x cubed equals negative 8. And then this time, since it's a cube and not a square, to undo cubing something, then I need to take the cube root of both sides. So I'm not just doing the square root, I'm doing the cube root. Cube root of x cubed is x. And then the cube root of negative 8, remember we're allowed to do a cube root negative if there's a negative inside. And the cube root of 8 is 2, and if it was negative 8, then it's negative 2. And remember that's because if I do negative 2 times negative 2 times negative 2, that would equal negative 8, right? We're allowed to have a negative inside a cube root and still get a real answer. That's fine. Okay, the next one in D. So this time we're back to x squared. I'm going to subtract the 16 over to the other side. So we get x squared equals negative 16. So this time we're doing a square root, and when we do that root, now we have a negative inside a square root. This is the one where before we would have just said no real solution, but now we know how to deal with this. So we take the square root of x squared, we get x. And then to fix this one over here, remember we can still do our plus or minus, but then to take that negative out, we put an I, because I is the square root of negative 1. And then we still have our radical 16, but now it's a positive because we pulled out the I. Then 16 is a perfect square, so that's going to be x equals plus or minus. Square root of 16 is 4i. Right? So normally before it would have just been plus or minus 4. If it was positive, no real solution if it was negative. Now, if we see that negative, we're just going to end up with an I in our answer. So it's an imaginary answer rather than a real. Same idea on the next one. This time we're going to subtract the 19 on both sides. So we get 2x squared equals negative 16. Divide by 2 on both sides. We get x squared equals negative 8. So again, we run into a situation where we're taking the square root where there's a negative inside that square root. So then we get x equals plus or minus. We're going to take out the I, and then we've got our radical 8. And then this time 8's not a perfect square, but we can simplify it. So we get x equals plus or minus 2i radical 2. Because 8, remember, if I break that down, that's a 2 and a 4. 2 and a 2, so there's a pair of 2's and a 2 by itself. So 2 comes outside, 2 stays inside. Only difference is we had to take out the I to start with, so it's 2i radical 2 with your plus or minus. All right, then our last one. Again, same idea. We want to divide by 3 on both sides. So x squared equals negative 8/3. So this time we're dealing with a fraction inside of our radical and a negative inside the radical. So then we get our x equals, we still have our plus or minus. We have a negative in there, so I'm going to go ahead and pull out the I. And then remember when it's a fraction, you can split this. So I'm going to put radical 8 on the top and then radical 3 on the bottom. Then we can do a couple things here. We can simplify the radical 8 on the top. Move up here with more room. So we get plus or minus I. We just did radical 8, and it was 2 radical 2, right? So 2I radical 2 on the top. And then on the bottom, we've got radical 3. Remember, we don't want to leave a radical in the bottom of a fraction. So we're going to multiply by radical 3 over radical 3 to rationalize. So then we get x equals plus or minus. Still have our 2I, and then the radical 2 times radical 3 makes radical 6. And on the bottom, radical 3 times radical 3 is 3. So that's our finished answer there. So same idea there, just a little more simplifying with the radicals and stuff. Okay, kind of putting together all the stuff we did in the last unit to now actually solve equations and be able to simplify our answers. Okay, so that's taking where we have something squared or something cubed or to the 4th power, and then doing a radical to get the x by itself. We're also going to do the opposite of that, or kind of the inverse of that. We're going to start with equations with radicals and then get rid of the radicals to solve for x. So on these, kind of the first few steps is we always want to isolate the radical to get it by itself on one side of the equation. Then if it's a square root, we'll square both sides, cube root, cube both sides. Anything else bigger than that, same idea, right? So on our first example here, we've got radical 2x minus 1 equals 3. I'm looking at this radical part. Everything on this side of the equation is inside the radical. So that means that that radical is isolated on the left side of the equation. So then once we've got that isolated here, we've got our square root of 2x minus 1 equals 3. To get rid of the radical, I'm going to square that side of the equation. Remember, a radical and squaring something, those are inverse operations of each other. Now, if I square that side of the equation, I have to square the other side of the equation. And then the square root of 2x minus 1 squared. You don't have to write that out in FOIL or anything, because remember, the whole point here is we're squaring it to get rid of the radical. So then all that's left on the left side is 2x minus 1. And then on the right, 3 squared is 9. Then I'm going to add 1 to both sides, so 2x equals 10. Divide by 2 on both sides, so x equals 5. Now, the one other thing with radical equations is we always want to check our answer, because with radicals, we could end up with something where when we plug it back in, we actually end up with an answer that doesn't work. Remember, when you square something, when I do this squaring part here, you're introducing a part where you could have a negative, but you're making it positive. So sometimes that can create an extraneous solution, and we'll kind of see that later on. But just know that anytime you solve a radical equation, you need to double check your answer just to make sure you don't get one of those extraneous solutions. So I'm going to plug in the 5. That would be 10 minus 1, so that's 9. And the square root of 9 is 3. So this checks out, and our answer works. Okay. All right, same thing on our cube root over here. We're going to, this time though, notice that with our radical, oops, switch that there, only the x is inside the cube root. So I need to get rid of everything else on the other side, on this side of the equation. So I'm going to add 1 over here to get rid of that. We get 2 times the cube root of x equals 4. This 2 is also not inside the radical, so I'm going to divide both sides by 2. And now we have the cube root of x equals 2. Now I've got my radical by itself. Now this time, since it's a cube root, to undo a cube root, I need to cube both sides of my equation. The cube root of something cubed just gives us x, and then 2 cubed is 8. And then again, real quickly, we can check our answer just to make sure. So 2 times the cube root of 8 minus 1 should equal 3. The cube root of 8 is 2. And that's 4 minus 1, which is 3 equals 3. So it also checks out. Okay. So there's where if you have a radical in your equation to start with, we want to get the radical by itself and then square it or cube it to get rid of that radical and then solve just like you normally would. Okay. All right, go try homework 1. We'll go over questions next time.